Here we go. Good old Anne. Was that you with the knuckles there? Wow, that was impressive. Energy is the ability to do work. Work is the ability to apply a force over a distance. So in other words, you know an object has energy if it can somehow exert a force over a distance. What is the minimum amount of work it would take for a 55-kilogram student to climb a 6-meter high flight of stairs? Well, work equals, there's 3 definitions of work. There's force times distance. There's also the area under a force versus distance graph. And there's also change in potential plus change in kinetic. Which one am I going to use here? To be honest, either of these two. The reason I said minimum amount of work, that's my hint, Tice, to say assume they're not changing their speed. Because if they were changing their speed as well, then they'd be doing more work. They'd be both changing their potential energy and adding some kinetic energy. Either of these is going to give you which force? Gravity, mgh, or if you go change in potential, because their initial potential is 0 and their final potential is mgh. In fact, you can actually get this equation from here. Oh, we got a latecomer. Let me pause the video. All right, so it's going to be mass 55, g 9.8 times 6. 1 mark apparently for this. Where's my, there we go. Come on. 55 times 6 times 9.8. Do you get 3,324? Sorry, 3,234. I think I flipped those. 3,234. Although I'm going to go to 3 sig figs because that's what we've decided we're going to go to. So I'm going to go 3,230 joules. Half mark for the equation. Half mark for the answer, but if you got the right answer, full marks. Ooh, a little multiple choice here. A ball is 5 meters above the ground and is falling at 5 meters per second. What is its total energy? Mr. Duke, you haven't done one like this. What do you think the word total means? What mathematical operation does the word total usually imply? Add. I think energy total is going to be the potential plus the kinetic. Not change in, because they just want it at this point. Okay. Well, the potential is going to be mgh, and the kinetic is going to be a half mv squared. Mass doesn't cancel, because I don't have a mass in E total. Total energy is going to be m2 g 9.8 5 plus 0.5 5 squared. I think I can do this in my head, because this is 10 times 9.8. That's 98. Oh, I guess I'm going to cross off that, and because it's clearly going to be bigger than 100. See how I did that without even, yeah, wasn't that nice? I've turned it into a true-false question now. In fact, you know what? I'm willing to bet it's that, because I'm pretty sure this is going to be bigger than 2. It's going to be 25.
You put the mass as 5.
I put the mass as 5. Oh, and the second one as 2? Well, that makes it even easier. Good gosh. So here I had this right. M, G, A. But there that should be a 2. Oh, that makes it even easier, because it's going to be 5 squared is 25 times 2 is 50, half of 50. It's going to be 100 plus 25, give or take. Yeah, 120. Yes?
Yeah.
In my defense, I did get the right answer without bothering to finish the whole question, which was kind of clever. So apparently I could have made that mistake and gotten away with it, because I just crossed out everything that I knew that had to be wrong. By the way, my test will have some multiple choice and some written, and I'll give you some hints about the test. If you're not crossing off obviously wrong answers on multiple choice sections as you go along, that's a great habit to get into. Just saying. Graph work. Well, why can't I go like this? I have students every year that say, hey, Mr. Dewick, the force is 200. This is wrong. The distance is, why can't I go like that? And why do I need the area?
Because
There's a changing, the force is not constant. That would only work if the line looked like that. In which case, by the way, force times distance is the area because you're multiplying. That's one of the reasons I gave you those graphing tricks last lesson. So I'm going to have to get the area under a graph. Okay, that's kind of cool. I'll break this up, Jake, into a triangle and a rectangle. I double checked. They want me to go from 0 to 5, so they want the whole area. I'll call this area 1. I'll call this area 2. Area 1 is going to be base times height divided by 2. The base looks like it's 1, 2, 3. The height looks like it's 200 divided by 2. I can do that in my head because 200 divided by 2 is 100. It's going to be 300 plus. Right away I would cross that answer off. I'm telling you, because it's going to be 300 plus something. Area 2 is going to be length times width, where the length is 2 and the width is 200. It's going to be 300 plus 400. Jake, I can do that in my head, in your head. What is 300 plus 400? Yay! 700 joules of work. Where did that work go? Two things: causing the object to speed up and probably heating up the floor, friction, heat. Unless it was frictionless, then it would be all going into speeding things up. Again, on ice, is there much friction? This is why when you push something on ice, it speeds up so much faster because so much more of your work is going into its kinetic energy. Oh yeah, different way to think about it, because we've talked about it in terms of force and in terms of acceleration, but you can also call and think about it in terms of energy and wasted heat. Oh, good, I was hoping I'd done a question with that answer. If the graph in number 4 represents the work done, find the speed of the mass when it reaches 5 meters. The mass is initially at rest. Well, work is also the change in potential plus the change in kinetic. And I don't think this question implies that there's any change in height. So this is going to be KE final minus KE initial, although it did say that we start at rest. How much work? 700. That equals a half mv final squared. I think, Addie, I can go times by 2, divide by the mass, equals VF. Oh, how do I get rid of a squared? Square root. I think it's going to be 2 times 700 divided by 4, square root. 18.7. Woohoo! A. What did you find in number 4? The work. By the way, I guarantee you're going to see 4 and 5 combined in one question. I guarantee there's going to be a question on your test where I give you a graph, and then I say, tell me how fast or how high. Yeah, I don't know. The work is in the graph, the area underneath thereof. So, okay? These, by the way, it was questions like this that nobody asked me from lesson 1, which was driving me crazy. Just saying. Escalator. An escalator shown below is used to move 20 passengers a minute. You know what? I think they snuck the time in. I think the time is going to be 60 seconds. I don't know. Let's see. Which is 5 meters above, to the second floor, which is 5 meters above the first floor. Assume the average passenger mass is 60 kilograms. Check. What approximate power must the escalator power? Is work over time, which is force times distance over time. Let's try this method first. I do recall also that ended up being speed, but I don't see a speed in this question anywhere. So I think I'm going to try, and I do see a time, 60 seconds. They snuck that in by using an English word, but I got that. Which force? I think this is going to be mgh. The force is mg, and the height. This is the change in potential energy. This is how escalators work, by the way. It's also why you may notice escalators all move at a fairly constant speed. I'm willing to bet it's a standard power motor that they use in every escalator here in North America, pretty much. There you go. It's also why you may notice the big, long escalators, like the ones sometimes coming out of SkyTrain, don't move as quite as fast. Anyways. M, mass. Oh, 20 passengers at 60 kilograms each. G, 9.8. Height, 5, divided by 60. I can do this one in my head. Holy smokes, because the 60s are going to cancel. And this is really 5 times 20. This is 100 times 9.8. I think the answer is 980 joules. Oh, joules, Mr. Dewick. Wait a minute. Power is measured in what? Watts. I don't see 980. Oh, yeah, there. I went to 2 sig figs, apparently. I don't know. This assumes that this motor is 100% efficient. Is that right? Yes? See? Number 7. How much work is required to stop? Okay, work. My first thought, Jake, is work equals force times distance. I don't see a distance here or a force here anywhere. My second thought is work is the area under a... I don't see a graph here anywhere. Oh, the third definition of work. This one is not on your formula sheet. It's the change in potential plus the change in kinetic. We call this the work energy theorem. You need to commit this one to memory. I don't see a hill mentioned here anywhere. So I think I'm going to go work equals KE final minus KE initial. And I think I can safely say that because it says it's going to come to a stop. It's going to give me a negative work, but friction is also acting in the opposite direction. Really, the negative is just telling me I'm losing energy. How much work is friction doing? I'm going to give the positive scalar answer, I think. They just want the magnitude. The work is going to be a half mv final squared. It's going to be 0.5, 1200, 10. Oh, wait a minute. Why can't I use the 10? I'm going to be really lazy. I'm just going to divide by 3.6 right in the brackets there. A half times 1200 times bracket 10 divided by 3.6 close bracket squared. You get 4,630 joules. B. Yeah. Good. Happy joy? Turn the page. Let's go for a swing. It says, use the following information for number 8 and number 9. Tarzan swings from his vine from a height. Okay, so here's my initial spot right here. At the end of his swing, he's only 2. So here's my final. Is there a change in height? Is there a change in speed? Is there a yucky, curvy path? I'm kind of leaning towards conservation of energy right now. Now, the law of conservation of energy is not on your formula sheet. I was working with somebody. Let me do that, by the way. It's going to melt everything. I was working with somebody this morning, and they hadn't memorized the law of conservation of energy. You need to memorize the law of conservation of energy. This is not the law of conservation of energy. What's the law of conservation of energy? It says this: everything before equals everything after. Everything initial equals everything final. It says this: KE initial plus PE initial equals KE final plus PE final. Then, Tyler, I also read the question carefully, and I said, hey, does this question want me to include heat? Does it mention friction or heat or anything like that? It does. So whatever's left over must have gone into heat. That's the balancing number. And that's the work done by friction, by the way. Are any of these 0? What's my initial speed? Oh, cool. What's my initial height? Not 0. Hey, PEI gets to stick around for a change. Province, really. What's my final speed at the top of the swing on the other end? Oh, What's my final height? Not 0. Okay. So I'm going to get this. The heat equals PEI minus PEF. What's potential energy? MGH, I guess initial, minus MGH final. Do the masses cancel here? There's no mass in heat, so no. Okay. Heat is going to be Tarzan's mass 75 times 9.8 times 2.5 minus 75 times 9.8 times 2.4. I think I can do this in my head too, because I can factor out the 75 and the 9.8. So it's really going to be 0.1 times 75, which is 7.5 times 10. The answer is going to be really, really close to a little bit less than, is it A? Is it?
Yeah.
Yeah, it's going to be slightly less than 75. Okay, you guys want me to actually type the numbers in? Fine. $73.5. What? Heat joules. If there were no friction, oh, that's nice. What would Tarzan's speed V be at the bottom of the swing? So now, there's final. Is there a change in height, Jake? Is there a change in speed? Is there a yucky, curvy path? I think this is a job for conservation of energy. Plus heat. No heat. Are any of these 0? Well, we're starting out at rest and we're ending up on the ground. Yay! This isn't going to be too bad at all. I'm going to get mgh initial equals a half mv final squared. Oh! This time, Rob, the masses do cancel. Doesn't matter whether it's Tarzan or Tentor the elephant. They'll both be going the same speed, assuming the vine can hold the mass of the elephant. Not that likely, but we can use our Sesame Street imagination and pretend. What do they want me to find? Oh, it's going to be 2ghi equals vf squared. Hey, Rob, how do I get rid of a squared? Yeah. Vf is going to be the square root of 2 times 9.8 times 2.5. Was that the original height? I should be able to do this one in my head too, because this is really the square root of 50. Square root of 50, it's going to be right around 7. Oh, 7 or 6.9. You know what? It's close enough that I have to crunch it. Oh, exactly 7. Not 6.9. Didn't know it would work out evenly, but yes, it would. Ty, you're looking a little tired. A little sleepy. Carol's in pajamas. Let's wake you all up. Let's go on a roller coaster. Woohoo! Here we go. Roller coaster car of mass 1,000 kilograms traveling with an initial velocity is 18 meters above the ground. It drops to the ground and climbs a 10-meter high hill. So I guess this is going to be initial, and this is going to be final. How fast? Oh, wait a minute. No, in part A, that's final. Well, that's nice. How fast is it traveling at the bottom? Oh, I bet you that's why I made part A 3 marks and probably part 4 is 4 marks because less stuff cancels out. I'll bet you. Does this question mention heat? No. Well, cool. Oh, sorry. Quinn, is there a change in height? Is there a change in speed? Is there a yucky, curvy path? You know what this is a job for? The law of conservation of energy, right? Plus, Mr. Dewick, equals. Plus heat. Oh, no heat. Are any of these 0? Did we start out at rest? No. Okay, that's sneaky, Mr. Dewick. Oh. That'll be 0. A half mv initial squared plus mgh initial equals a half mv final squared. Oh! Devin, what do you notice here? Have you been on a roller coaster before, Devin? Did they make you step on a scale before you got on the roller coaster? Did your little math nerd mind ever wonder why they didn't make you step on a scale? It should have. But the answer is, as long as there's no friction, or in real life, if we grease things down so that we get friction really, 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 really small. Yay. I'm going to do one more thing. What am I trying to get by itself, Dev? There's a 1/2 right here. I'm going to go times by 2, times by 2, times by 2. You don't have to. You could divide by 0.5 square root, but you may have noticed if I can be lazy and clever and elegant, I'll try to be. Because, Rob, that happens, and I kind of smile here because what I really end up getting is VI squared plus 2AD. I know I wrote G for the acceleration. I know I wrote H for the distance, equals VF squared. I get that lovely equation from Unit 1 that I promised I would prove to you that where it came from, and I never did in Unit 1, but it just kind of pops out here. How to get rid of a squared? This was your cue. Okay. Have we got room? Oh, good. So VF is going to be, was it 4? Where's my numbers? 4 and 18. 4 squared plus 2, 9.8 times 18. You're going to go look 368 meters. Oh, square root. That's not bad. 19.2. It's about 70 kilometers per hour. That's okay for a roller coaster. There's the one I think in Cedar Springs, Ohio, that does crack 100 miles an hour, about 50 meters per second. So more than twice that speed, but okay. 19.2 meters per second. This is worth 3 marks. How would I give out the marks? I would give you 1 mark if I saw that. I would give you 1 mark if I saw that, and then 1 mark for your answer. How fast is it traveling at the top of the second hill? Okay, so now, final is right there. Hey, Mac, is there a change in height? Is there a change in speed? Is there a yucky, curvy path? This is a job for conservation of energy. Now, Colin was suggesting, are you suggesting that I make this initial? Is that what you said? Something about the ground?
No, just make the final for the ground.
Oh, Colin. You just impressed me. About time. No, Colin, you just impressed me. Here's what Colin is saying. Hey, Mr. Dewick, why don't I let this be ground level and just have my height be 18, 10, 8? Ooh, that's so clever. I'm going to do it that way. You could also do it with the 18 and the 10, and it'll all work out. But that's really clever, and it's so clever on a Monday morning, which doesn't happen very often with you guys. I think I'm going to, in fact, you're going to get a candy for that. Ready? So we start out with the KE initial. PE initial equals KE final plus PE final. And so you're saying by doing that, ha-ha! In fact, I think what you're saying, if I'm not mistaken, by you making that clever little move there, copy, you turned it into that question, did you not? Yeah? That was quite clever. I think that's the first time I've had a kid spot that in a long time. So, I think I'm going to get this. V final equals the square root of 4 squared plus 2 times 9.8 times the change in height, 8. This is so clever because I can even just go backspace on my calculator. All I have to do is delete the 1. Oh. And then square root of that. 13, is it 13.1? Meters. How would I give out part marks there? So if you did it Collins' way, sorry? Meters per second, thank you. If you did it Collins' way, I would give you 1 extra mark if you crossed that off as well, and if you used the 8, and then 1 mark for the answer. There's your 4 marks. If you did it the long way, I think I have an answer key showing my marks breakdown for that. Let me just pause the video for a second. So if you didn't spot that clever move that we, again, because energy is a scalar, we can put ground level wherever we want, wherever it's most convenient. If you didn't spot that and you actually said, okay, nothing cancels, then I would multiply everything by 2 to get rid of the 1/2, and then I'd have VI squared plus 2GHI minus 2GH final, and you still get the 13.1. If you would be so kind as to give yourself a lovely score at the top of the page out of, what's it out of? 16? So let's do some question and answer tutorial questions. Lesson 2, number?
9.
Skier?
Yep.
Okay, cool. Let's go skiing. There's a change in height, there's a change in speed. I think this is going to be a job for the law of conservation of energy. Part A says, how fast is he traveling at point Z? Well, this is kind of strange because this time, as a little twist, I actually gave you the kinetic energy. So I think I can go like this. 10,500 equals a half mv squared. Was it 10A, 10B, or sorry, 9A, 9B, or both? 9A, okay. So they gave me the kinetic energy in joules. Did they give me the mass? Oh, you know what? It's going to be times by 2 divided by m square root. That's going to give me the speed right there. Okay? Is that all right? I'm not going to crunch that. In fact, what I'm going to do for the rest of the question for part B is I'll use this just as my KE initial. Instead of going a half mv squared, I'll just plug this in. Because part B says he loses this much heat energy. What's the maximum height? You know what? It's a change in height. It's a change in speed. I think I'm going to go like this. KE initial plus PE initial equals KE final plus PE final plus heat. Because it does talk about friction. You okay with that? Are any of these 0? Here's initial. Here's final. Prince Edward Island gets hosed again. Now, they're not a real province anyways. We all know that. Any else? Ty? KE final? Oh, at the top, if we're asking how high can they go, what we're really saying is they're coasting, they're slowing down, they're slowing down, they're slowing down, they're slowing down. How fast are they going right there when they get to the top for a split second? 0. That's why it's maximum height. Oh, no, don't cross that one out, Mr. Duke. Sorry, that one. Is that okay? It wants me to find this height because this is MGH final. I'm going to minus the heat over. This is going to be KE initial minus heat equals MGH final. Look, 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 look. And, oh, look, 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 look. I normally would go a half mv squared, but they conveniently told me what that worked out to, 10,500. Did they tell me how much heat there was? Oh, yeah, 3,200. That should get you there. I hope it will. I hope. Is that okay? Next! Good question. Number 10? Sure. At point A, a roller speed, oh, apparently I forgot to include the word roller coaster. Note to self, Mr. Dewick, fix that. You know what? That irritates me. Let me pause the video. A roller coaster has a speed of 19 meters per second. H1 equals, okay. Is there a change in height? Is there a change in speed? Is there a yucky, curvy path? You know what this is a job for? Conservation of energy. So I'm going to start out by going KE initial, P plus PE initial equals KE final plus PE final. The sad news is I don't think any of these are zero. We're never on the ground. Now, we could use Collins' trick, by the way, and say if that's 49 and that's 21, we could subtract them. But you know what? A lot of kids don't see that, so let's do this the longer way. This is going to be a half mv initial squared plus mgh initial equals a half mv final squared plus mgh final. You notice they didn't give me the mass? Thank goodness they didn't have to. If there was friction, they would have had to. Or heat, they would have had to. Have you been on a roller coaster before, Tyler? Yeah? Did they make you step on a scale before you went? Did you ever wonder why? You should have. Just saying. What are we trying to get by itself? Yeah. In fact, you know what? If I was really clever... Yeah, hustle back. If I was really clever, I would have gone point A, point B there. That's what I really should have done. Instead of using final and initial, that's even more descriptive now. Yes? I'm going to use this trick again. Ty? Times by 2, times by 2, times by 2, times by 2. Here the 2 cancels, and here the 2 cancels the 1/2. So I get this. V at location A squared plus 2GH at location A equals V at location B squared plus 2GH. You okay with that? And you said I'm trying to get this thing by itself? I agree. How will I get that 2GHB? How will I move this over? Subtract. Yep. Most common mistake I see, hint, 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 kids divide. I still haven't figured out why they suddenly do here, but I see it all the time. It drives me crazy. So I'm going to get V at location A squared plus 2GH at A minus 2GH at B. And that equals the speed at location B squared. Oh, Ty, how do I get rid of a squared? Square root? Sorry, I didn't hear you. I think it's going to be that. You take it the rest of the way yourself?
Yeah, thank you.
Okay, be careful with your type. I would type that whole thing in, hit equals, and then square root answer button. Should get you there. I like that question, I like that question, I like that question. There's going to be a roller coaster on your test. Possibly more than one. Because it's roller coasters. Is that all right? Yep. Lesson 3. Number 4. Nice. Now, there is an angle here. I did tell you on your test I'm going to keep everything level and scalar. I've flogged it, but it's good review, and it's a nice using everything. I think I'm going to have to do a picture. I'm going to draw my picture right here. So there's my ramp. This is also important. Underline, if you didn't already, that phrase there. Okay? It's being pulled up a ramp at a constant speed. First thing it says is, what force is required? Well, what are the forces acting on this object? Get the obvious one. Which I'm going to break into, you just saw because we did one very similar to this. I think the force that's pulling it up, which is the applied force, there's the normal force. Because we're going at a constant speed, I think the applied force is exactly the same size as mg parallel. So what force is required to pull it up? mg parallel, mg 2 lines sine. So 9 times 9.8 times the sine of 25. You okay with that? Then, part B says what power is required. Well, normally I go power equals work over time. The problem is they didn't give me a time in seconds here anywhere. But work is force times distance, still over time. Tice, what are you saying I can do with this distance over time? What is distance over time really? Did they give me a speed in the question? Holy smokes! Which force? You know what, Mac? I'll bet you the force from part A. That force times 1.5. I'll bet you, I'll bet you, I'll bet you. I mean, I like that in that it's a nice way for me to sneak in that second definition of power, and that part is fair game on your test next class. But I'm pretty sure on your test, on your test, I almost 99% positive I didn't put any angles. Yeah.
Number 9 on what else might
Did you look at my answer key online showing all my steps? Oh, could you check there first, and then I'll happily go over it next class if you're still stuck? I will do a 10-minute tutorial. Because which is number 9? You know what? I should look because I know there's one question I have to go over every year. It's the coming off of the slide one. Oh no, number 9. You'll be able to get okay if you look at my answer key. The toughest one on this ultimate review is this one here, number 18. So if you look at my answer key, if you can figure it out from my answer key, or first of all, if you figure it out on your own, I'll be really, really impressed. If you can understand my answer key, I'll be medium impressed. If not, I'll go over that one next class, and that's a pretty tough question. Yeah?
I was wondering on homework number 1.
Lesson number what?
Lesson number 1.
Lesson 1?
Homework we got on
Yep.
15B. Is there
15B?
Yeah.
You got that there was a typo? Were you here?
Yeah, but the way I got it was not using kinematics. When I was trying to
Oh, you got it a different way?
well, I used ES equal AT and
You got a force, so you found the... Oh, that'll get you... Oh, you know, and probably you'll end up doing the same... So did you do part A?
yeah.
See, if I hadn't done part A first and they gave me that graph, I might use your method. But the fact that I have the work, what I can really then say is work equals the change in potential plus the change in kinetic. And I think I can safely say the question didn't seem to imply any hill. So if it wants the mass of the object, it's going to be 2,500 equals a half mv final squared. If the speed, so the mass is going to be 2, did I say 2,500? I think I meant to say 250. Is my brain saying I said 2,500? I did? Okay. 250. I'll times by 2, that takes care of the 1.5. I'll divide by VF squared. That should also be the mass, so it should be 2 times 250 divided by 8 squared equals m. Humbly, I'll suggest probably that's faster than what you did. 3 lines. But yeah, you could get there by saying what? What did you use for your force?
Force 15, because at 60 meters the force on the ground is 15.
See, to me, I'll look over your shoulder. To me, I think I should be using a force of 7.5 newtons, the average force, because if you use the average force, you can get away with treating it like it's constant, because for the same amount of time it was below, because this is a straight line, not a curve, you can say I can take the average force, and that might get you there using force times distance. I'll look over your shoulder in a bit.
Also, doesn't that get the answer that you crossed out?
I don't know, let me see. Oh, you know why? Because we actually have to use the whole area, not the 250. So the whole area is going to be base 60 times height. The whole area is going to be base times height divided by 2. That's where the 14.1 comes from. Because I did say it initially started at rest, which is why I can say plus KE initial cancel. Sorry, I did too much there. Yeah, you're right. That's why I got that 7.81 initially. No, it's 14.1 if you start at rest and use the full area. Yeah. Is that okay? Any others? I'm sorry, lesson 3, number 14? Yep. $14. Oh, sure. Let's figure out how much power we need if the motor is 100% efficient, and then we'll figure out what the motor really is. You okay with that? So power is work over time. I think for an escalator, what force is the motor doing work against? That's not a force. Which force? Because I'm going to go like this. Force times distance over time. Which force does an escalator do work against? Yes. Okay, so this is going to be mgh over time. You okay with that so far? How much time? It says per minute. 60 seconds. How much mass? Well, it looks like it's 60 people times 50 kilograms apiece times 9.8 times a height of 10 meters. So if this motor was 100% efficient, okay, you know what? The 60s cancel. It's going to be 10, it's 500, I think it's going to be 4,900, I don't know, let me see. 50 times 9.8 times 10, I'm getting 4,900, yeah, 4,900 watts. Now that's if it's 100% efficient. How efficient is it really? So 65% as a decimal is 0.65. And that was calculated by the power we got out divided by the power we put in. We got out 4,900 watts of power. This is going to be the actual power of the motor. The other reason I knew that the power, that what I'm looking for was on the bottom was the smaller number, the amount of work that we get out is going to be on top. And I always know we don't get more out than we put in. Otherwise, we get a Nobel Prize. Cross multiply. So you'll get power in equals 4,900 divided by point, right? Stuff moves diagonally, divided by 0.65. That's where the 7,450 watts came from. Is that okay? There will be a question or two dealing with efficiency as well. Okay. Any other questions? Okay, let me pause the recording for a second. Okay. So for some hints from your review, I like number 2, I like number 2, I like number 2. Number 2 is a nice question. I like number 4, I like number 4, I like number 4. Number 4 is a nice question.
The screen's still frozen.
Oh, the screen is still frozen, Mr. Dewick. Why don't you unfreeze the screen? Although I'm just calling them out so you could really write down the numbers that, you know, okay. What did I say? 4, I said, yeah. 6 is good, I like 6.
Do you like it though?
I like number 6, I like number 6, I like number 6, I like number 7, I like number 7, I like number 7. I like number 8, I like number 8, I like number 8. There's definitely going to be a graph question like number 9, although in number 9 I notice I'm asking you to find the mass. I can't remember if I did that or not, but there's definitely going to be a graphy. Well, oh, you know what? How about number 10? Sure, that works. I like number 10, I like number 10, I like number 10. I like number 12, I like number 12, I like number 12. Love number 13, I love number 13, I love number 13. It's a roller coaster. I like number 15, I like number 15, I like number 15. I like number 16, I like number 16. So these are examples of how I might give you a graph and have you do something with it. I like number 20, I like number 20, I like, oh, water slides. Yeah, I like number 20. Those are fun. I like number 22. I like number 22. I like number 22. I like number 26. I like number 26. I like number 26. I like 27. I like 27. I like 27. I like 28. I like 28. I like 28. I like 32. I like 32. I like 32. I like 33. I like 33. I like 33. Ooh, water slide. Oh. This one's a little bit... Yeah. I like 34B. I like 34B. I like 34B. I like 35. I like 35. I like 35. So 38 and 39 are cool, but they're slanty with angles. I mean, try them, but I've told you on your test this time I'm going to keep everything in a nice straight line. Scholarship questions, So there's some hints there.